All right. Thank you, everybody, for joining us for Pearl Engineering's fourth webinar, Code Talkers, Importance of Being in Compliance. We're going to get started here. And first, I'm going to talk about a little bit of Pearl Engineering's capabilities for those of you that don't know us that well yet. I will be your moderator, Mike Evans. I've been with Pearl Engineering for 2 years. I'm an engineering associate on the mechanical team, and I do a lot of project management and on-site assistance for our clients. Our civil structural engineering services include designing of new structures, modifications of existing structures, monorails, and other lifting devices, condition assessment of structures, which will actually be next month's topic, stack chimney and ductwork evaluations, roof maintenance and replacements. Our mechanical engineering team includes piping and pumping system designs, energy conservation analysis and design, HVAC evaluation, process systems assessment and design, also condition assessments of equipment, machinery, troubleshooting and modifications. We also have a lot of experience with auto pipe, piping, flow, and thermodynamic analysis as well. Electrical engineering, we do a lot of power distribution, control systems, hardware and panel design, construction packages. Our project management includes conceptual design and planning, procurement and processing services, construction management and field supervision, and also lead consulting. Our safety team does a lot of plant safety evaluations and improvements, fall protection design and evaluation, and we also offer OSHA training and compliance consulting. Our design services include building information modeling, or BIM, with Autodesk AEC Design Suite. The drafting services we offer are rendering services using Revit, 3D project design also in Revit and AutoCAD, and we have extensive knowledge of Faro 3D laser scanning. We also have a webinar all about our 3D scanning capabilities on our website and our YouTube channel. All right, going back, I would like to introduce Jeff Pearl. He is our president and principal consultant specializing in structural engineering and project management of industrial projects. He's also a PE in multiple states and provinces. So hello, Jeff.
Good morning, everybody, or good afternoon, rather.
On our mechanical team, we're going to have Mike Anderson, who's a senior project consultant at Pearl Engineering, specializing in mechanical engineering and project management on boilers, turbines, fuel handling, and power and industrial process systems. He has over 15 years of experience in the power industry, including 4 years in boiler power department at a paper mill. He's also a PE in multiple states.
Hi, everyone.
So, Mike, you're going to get us started today. And what is the importance of being in compliance? I know you have a pretty awesome history and timeline here for us, so take it away.
When you're talking about being in code compliance, I guess you have to look at what are the codes and what do people mean when they say the code. As someone with a power background, I think the boiler pressure vessel code when someone says the code, but there are codes for so many things, including FDA has codes and the NFPA and ASME has codes, and it's all just goes down to what are rules that are going to help keep everyone safe. So the American Society of Mechanical Engineers was formed in the late 1800s, and around the time of the Industrial Revolution, there were so many new technologies coming about, and there ended up being incidents and failures as in different manufacturing plants. Steam pressures are getting higher, trying to use higher voltages, and starting to use compressed air. Well, some of these catastrophes, it was at a shoe plant in shoe factory in Massachusetts in 1905. There was a large explosion and 58 people were killed, and that helped kind of prompt the ASME to develop the boiler and pressure vessel codes. You know, they kind of, there'd been discussion about that, and the states were kind of starting to make their own rules as they went along, but that really kind of kicked it off to where they started making codes and rules. You know, as buildings got larger, you started having, if you had a fire in a building, you had to make sure that people had evacuation routes. So it was all set up for safety for the people. You know, the basis of a lot of the codes doesn't change year to year. And, you know, most organizations publish a new set of codes every 3 to 4 years. But, you know, there have been advancements. If you just look at the, say around boilers themselves, back in in the early 1900s, there was no pulverized coal. You know, the pressures that they would operate at were so much lower than what they can now. Now they run, you know, 4 times the pressures that they could achieve back in 1920. So they've had to keep advancing, and the metallurgy's got better. When you look at the code in a broader sense, the code books, you know, that are the resource that everyone uses to go to reference the codes, you know, they are a good reference material, and they're to help establish that the designers, the engineers, and the mechanics working on the equipment are all following the same rules. And, you know, like I've talked a lot about the boiler pressures things, but you know, if you look at the boiler code, it has rules for what type of maintenance you can do on a boiler. And if you look back at the largest catastrophe, the worst incident we've had as far as like a maritime disaster is back at the end of the Civil War, 1865. There was a ship going up the Mississippi, a steam-powered ship back then, and they had 4 boilers on board, and they had to stop to make a repair. And the ship was full of 1,800 Union soldiers heading home at the end of the war. And they tried to hurry and expedite the repair. Well, they ended up just kind of sort of doing a temporary repair, you know, because there were no rules back then. There was no code. And later that night, they ended up blowing up the boiler. The entire boat exploded, and there was between 1,500 and 1,800 casualties. So if the code existed then, like it does now, that potentially could have been avoided. But there's so many areas that are covered by some sort of a code or a set of regulations. For example, if you were going to install a propane tank at your facility and it was going to send propane to a certain process to burn, you're going to have boiler and pressure vessel codes, because it is a pressure vessel. So it's going to have to be constructed by certain codes and regulations. You're going to need to make sure that you have safety relief valves on the tank. You're going to need to meet NFPA code guidelines for, you know, sending to the process. You have to meet ASME process piping code for the piping. You know, the list goes on and on. You got local and state regulations that you might need to have for access, or you might need a fence around it. So the list can go on, and the big thing is that you make sure that you have the right expert in that field, kind of evaluating the codes to determine what you need for your application.
Great. And Jeff, in regard to building design, do you have any examples in regards to that?
Oh yeah, I think that, Mike, you're absolutely right that previous accidents have been major milestones in developing building codes to protect lives. And just like you mentioned about the Civil War ship blowing up and the factory in the east there that blew up, that same thing in building designs and fires specifically. The most famous is the Triangle Shirtwaist Factory in New York, and actually in Greenwich, Connecticut, I think it was, or in 1911, and it killed about 146 people, where they were trapped in the building. There was no way to get out. The exits were blocked, and those codes, or those accidents, precipitated laws which became building codes of that, you know, we need to design a building that's safe. And one example would be, how do we separate buildings? So if you've got a matchstick factory built right up against my house, you'd think maybe there's a high risk that that could catch on fire and burn my house down. So therefore, there's laws and codes requiring that any building has to be so many feet away from another building, depending on what that building's occupancy is, whether it's a flammable hazardous storage type building, or if it's a warehouse that's storing plastic, or if it's a hospital or a school or an auditorium. When we can't have buildings separated far enough apart, or you have buildings or spaces, occupancies alongside each other, you have to separate them. So in the International Building Code, they address this under Chapter 7, and specifically under Section 706 is for fire walls, and 707 is for fire barriers. And so this is to separate an occupancy, like an office space, from a factory, or a storage area from a boiler room. So on that note, you have this separation. Well, the problem is, most of the time, those fire separation walls need to have openings in them so you can transfer materials, goods, have traffic, have exiting through those firewalls. So you have to address that. And those are covered under Section 716 for openings such as doors and window assemblies, and Chapter 717 for ductwork and penetrations to walls like that. Now, I know a lot of you might think, well, what does this got to do with us? That sounds really boring stuff. Well, yes and no, because the codes are governed by laws which are enforced. And so if there's a violation of that, it could go all the way back to the building owners of being, you know, liable because there was a fire and the fire came through those openings. And so in our real life examples that we see every day, or not every day, but in plants we see in industrial facilities all over the world, we've seen some gross violations on that. So for instance, you might have an overhead door that has a fire door. It's like, well, the fire door was designed to be installed there so in case of a fire, a fusible link would burn and cause a chain to release and cause the door to close. And that's all great, except for we've seen cases where the door was rusted shut or rusted open. So the fusible link, you could knock it out, you could break the link, and the door would never close because it's been rusted in place for so long, it's stuck and jammed up in place there. We've seen clients literally take the doors out and say, you know what, that rusty old door is not any good. Let's put a rapid roll-up door because we're going back and forth with forklifts through this door opening. Or clients have put new doors in and didn't bother putting any kind of closure or anything to address the fire separation of fire going through those areas. Other examples might be, I've seen cases where clients have literally routed pipe right through the corner of the door opening. So the pipes are going to be jamming the door open and it would never closed. And other examples, duct work that's routed through firewalls and there's no fire damper on them. So if there's a fire and the fire comes blowing down through a forced air system or exhaust system through that wall opening, it's going to suck the fire right through as if there was no wall at all. You might as well have a screen door there. Other examples is PVC pipes routed through firewalls and there's no fusible links on those. But there's a lot of creative solutions you can have for those things. So if somebody wants a rapid roll-up door in a firewall, you definitely can have that and put it on one side of the wall, but you should still have that fire door on the opposite side of the wall that's set in place that it will close. And we've had conveyors that come through a firewall, and if it works out, you can have that conveyor have 2 conveyors that stop on each side of the firewall. Something wrong with my camera thing here. And so the fire door could come straight down between the conveyors, and you have to time it and have it all worked out for packages to not block the doors. We've had other examples where we had a conveyor that was routed through a building firewall, and it was a continuous conveyor because the material was a food process material that was raw, and so it wasn't packaged at all, is what I'm trying to say. So you couldn't have a break in the conveyor, all the material would just fall through the slot in the conveyors. In that case, that was a pretty creative solution. We worked very creatively with the local fire department chief, the local building inspector, the building code reviewer, and the state fire inspector, and came up with a solution where we ended up, the conveyor ran continuously through uninterrupted through this firewall opening. And then what we did was we put a deluge system on each side of the firewall with smoke and heat detection systems outward from the wall. So if there was a fire at either side of the room, that heat or smoke detector would detect it, and it would release the deluge system to start dropping deluge water to basically create a water door, essentially, of falling water to stop the fire. But it also had a disconnect to the conveyor to shut the conveyor down, so the conveyor couldn't keep having material going up and down that maybe is on fire. So there's a lot of creative solutions, and I think that my advice to anybody listening that's a client or a manager of a building or a factory, to go out and look at those fire doors, look at those firewalls, identify them, put your signs up that says keep fire door closed, or look at a creative solution for, like I said, fusible links, magnetic door hold openers with smoke and heat detectors on each side of the door to release the door. Please, I urge you to consider that. That's all I've got.
All right, thank you very much, Jeff. If anybody has any questions in regards to our Code Talkers webinar today, you can please reach out to me at this email or phone call, and also please follow us on LinkedIn, as we are very active, to stay tuned to all of our future webinars and material that we put out. Thank you very much, everybody, and have a great day.
Thanks.